Hi, good afternoon, guys. So nice to talk to you on the Zoom today. And here are some of the questions that you guys have for Zoom. Someone asked me about those earlier today. So let's take a look at that. So for number 16 and 17 on the 4.1, 4.2 study packet. Okay, so let's see. So 4.1 and 4.2 study packet. And here's what we got. Number 16. So this one is all about graphing. So that's something you guys kind of struggle a little bit. So graph y equals 3 log x and then minus 1. Again, if the base is not shown, so that's considered 10. So let's just compare this one back to the transformational form. So it's a log base b and then of the quantity x minus h plus k. So the value of a obviously is 3 and the base is 10. And then h, if that's not shown, that's 0. And k, obviously, it's negative 1. So anytime that I deal with the log functions, so we do know that's a logarithmic functions. So there's no HA, there's only VA. And the way to find VA, it's always the value of H. So that means x equals 0, because that's the value of H. So that's VA, the vertical asymptote. So we've just started with the graph. So we need the x-axis and the y-axis for the template. Okay, let's see. Okay, so I need the x-axis and the y-axis for the template here. Okay, so the x-axis and then the y-axis. So now, in order to get the point, well, let's start with the VA first. So VA, which is the vertical asymptotes. So for that part, we do have x equals 0. So let's use different color for this one. Okay, so here's VA, which is the y-axis. And now we need to get some points. Now the way to get some point, we can use that the formula, which is that the same log base b. Okay, so one thing we notice, if that's log base b of b, that's always considered 1. So we do know that the base is 10, so we can use x equals 10. So if that's log base 10 of 10, so another thing that we can do, it's about the xy table. So let's say that we plug in 10 for x. So we got log base 10 of 10, which is 1. 1 times 3, that's 3. 3 minus 1, then that'll be 2. So 10 comma 2. So let's say this one is about 5, 10. I just want to change the scale a little bit. You can go by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you can go by 10 comma 2 like this. Okay, you can always customize the scale. So 10 comma 2, that's the point right there. So now I need to get one more point. Another thing that we notice, so log base 10 of 1. Okay, so log base 10 of 1. And then that'll be considered 0, because 10 to the power of 0, that's 1. So that means we want to put in 1 here. So 0 times 3, then that'll be 0. 0 minus 1, then that'll be negative 1. So we got 1 comma negative 1. So 1, somewhere that's over here. Negative 1 down here. And then basically all you need to do is just connect the dots. Again, the curve, this point right here, is getting very close to the asymptote, but never touch any point on the asymptote. So we just want to connect those two dots. So eventually it's going to be like this. Okay, so that'll be your log graph. So make sure that I put in the arrow. And the domain for this one, so x is greater than 0. Or you can just say that the interval notation, negative infinity, 0 to positive infinity. And then what about the range? So the range would be all real number. So we can just put in negative infinity to positive infinity. Okay, so let me fix this one here. So that one for the range would be from negative infinity to positive infinity. Okay, so that's number 16. And now 17. 17 is quite similar. So let's take a look at that, number 17. So for 17, we do have... Okay, let me change that, the color here. So for 17, we do have y equals -3 log of x plus 1. Again, identifying the value of a, which is -3, so you might be wondering it's a reflected over the x-axis because the negative sign changed. And then the base, again, if the base for log is not shown, it's always considered 10. You probably want to put 10 right here. And then the value of h. So this one, it's x plus 1, so it's considered x minus -1, because negative times negative is positive, so h is -1. And then k, if that's not shown, it's always 0. So first thing that you want to do, well, the template is already given for the xy plane. So I just want to set up the x-axis, y-axis here. Normally I do have the grid, but the thing is that I need to set up the the x-axis and then the y-axis. Okay, so you may notice, so VA, which is -1. So -1. Okay, let's change that. It's a dotted line. So -1 somewhere over here. Okay. And now we need to get some points. So the way to get some points, once again, we use the XY table. Okay, so again, same log base 10. So then that'd be 1. So let's just change that x value to 9. So 9 plus 1, that's 10. So log base 10 of 10, that's 1. 1 times -3, then that'd be -3. So we got 9 comma -3. So let's count it by 3 this time. 3, 6, 9. Again, for the x-axis, you can change the scale. You can do anything you want for the x-axis. So 9 comma -3. So here's 1, 2, down here, -3. So that's the first point we have. Another thing that you want to make x equals to, again, one thing we notice, log base 10 of 1, log base 10 of 0, then that'd be 1. Well, let's see. No, log base 10 of 1, then that'd be considered 0, because 10 to the power of 0, then that's 1. So in order to make this one, the quantity is 1, so that means x is going to be 0. So 0 plus 1, log base 10 of 1, so that's 0. And then 0 times -3, which is 0. So we do have 0, 0. So that's another point we found. And now, basically, we just connect the dot. Again, the graph is reflected over the x-axis. So that means the curve is declining. So it's decreasing, going through this way. Okay, like that. Okay, so that would be your logarithmic function, the graph. And again, to find the domain, so the domain for this one is from -1, but -1 is not included, all the way to 0. And then the range is from -infinity to +infinity. Okay, so now let's see what else that you have. And people are saying that questions on the homework 4.3, number 23. Okay, we'll take a look at that. Okay, so 4.3, number 23. Okay, so just need to set up the new slide here. Okay, so 4.3, number 23, let's see what is that about. So use the log of logarithm to expand the expressions. Okay, so this one, it's on sections 4.3. And it's number 23. Okay, we'll take a look at that. So we got log base 5 of q root of the quantity of x squared plus 1. So now you want to apply the properties of logarithm to expand it. So first thing that you want to do, you want to rewrite it. So this one is log base 5. It's a radical form, so let's rewrite it with the exponential form. Okay, so which is x squared plus 1 quantity to the power of 1/3. And you may notice that we can use the power to coefficient property. So the property part of the formula we have, log base b of x to the power of r. So this one is written as r, log base b, and then x. So this one is a power to coefficient property. So bring down the power, so we got 1/3 log base 5 of x squared plus 1. And anything else that we can do at this moment? So according to the quantity, it's a sum, so we can expand it unless this one's the product. So nothing we can do at this moment, so we just leave it. So it's 1/3 log base 5 of x squared plus 1. Okay, so now let's see what else that we have for the rest of this. So the next question, what we got here, it's section 4.4, number 53 and number 57. Okay, so let me take a look at those two problem here. Okay, so 4.4, 53 and 57, it's about solving the exponential functions and the logarithmic functions. Okay, let me see, 53. Okay, so 53. Okay, again, I need to use another slide right here. So this one is for the book work, section 4.4, number 53. Okay, so solve for x. So we do have 2 to the power of 2 over log base 5 of x. Okay, so that equals 1 over 16. So some people might be freaking out with the setting here. So it's like 2 to the power of a crazy exponent. So nothing to worry about. So again, according to one of the lecture example, is saying that you want to convert that to the same base. So basically the left hand side, we just want to rewrite it. But now for the right hand side, so 1 over 16. So this one is written as 2 to the power of negative 4. Okay, so 2 to the power of negative 4 is 1 over 16, because you multiply by the 2 in the denominator 4 consecutive times. So since we find a common base, so basically we can just cross out the 2, the common base 2. And what's left here is just 2 over log base 5 of x. So that equals negative 4. And then this one, you guys thinking about that, can I cross multiply it? Yes, you may. Cross multiply. So once you cross multiply, you'll deal with that 2 equals negative 4, and then log base 5 of x. And then from here, divided by negative 4, so we do have negative 1/2. So that equals log base 5 of x. So you might be wondering, anything that we can add or subtract or multiply or divide both sides? Well, nothing you can do at this moment. So what we can do, we can convert it from log to the exponential form. And you can see that the base is what? 5. So 5 to the power of negative 1/2. So then that equals x. So 5 to the power of negative 1/2 is considered 1 over root 5. Negative exponent, so we convert that to the reciprocal form. And then multiply by root 5, top and the bottom. So we do have root 5 over 5. So that's the value of the variable. So again, come up with the common base, cross multiply, and then try to isolate that log base 5 of x. And convert it from log to exponential. That's a key step right there. And then solve for x. And then rationalize it. And now let's see number 57. 57, that's on the same sections. So someone asked me about the other one earlier today. So now for number 57, again, this one is sections 4.4, the book work. So we do have x to the power of 3 minus x, so that equals log of x plus 1. So first thing that you want to do, you want to come up with the exponential form. So try to convert that to the exponential form. We do have 10 to the power of x to the power of 3 minus x. So that equals x plus 1. Now you might be wondering, well, nothing we can do, even we convert that to the exponential form. That's right. So there's nothing we can do with the exponential form. So now let's see what else that we can do. And according to the problem, this one you have to use the graphing calculator device to find all the solution of the equation. So in order to find the solution, you want to set that on the decimal. So y1, so you want to set that y equals x to the power of 3 minus x. And then for the other one, you want to set that y equals log base 10 of x plus 1. Okay? So once you set those two equations, you want to find the point where they intersect. And then you'll see that the x value. Okay, so let's do that on the decimal and see what happened. Okay, let me just turn on the decimal right here. Okay, just bear with me. So just want to show you this one here. Okay, so now for the decimal right here, you want to go to y equal. So on the left hand side, so you want to type in 10 to the power of x to the power of 3 minus x. So 10 caret to the power of the quantity, parentheses, and then x to the power of 3 caret again to the power of 3. Bring the cursor back down. And let's see what else. Minus x, close parentheses. Okay, so that's y equal, the one on the left hand side. And now let's find out the one on the right hand side. So y equals, so since we take that log base 10, so this one just left with, okay, let me go back to the previous one. So the right hand side, so that just turns out to be log base 10. Well, the other side is just x plus 1. I mean, you can type in this one too. Eventually, it's going to be the same thing. Or you can type in 10 to the power of x to the power of 3 minus x. And then y2, you want to put in x plus 1. So for this one, I'm going to put in x plus 1. Linear. And let's find out the point where they intersect. So it looks like we did the y-intercept here and also the other point. So eventually, so we do have x equals 0 and then x equals 1.136. Okay, so that's all the question you guys asked me about today. Again, anything that you need more refreshing, so just rewind the video or you can just fast forward. You can watch that as many times as you want. And please post up any comment, any suggestions, and also please give the referral to any people that who needs help for pre-cal. And also you can get participation points. Okay, so thank you for watching this video today.